Now we are going to learn the final revision of our confidence interval formula for P, where we're going to have the option of more confidence levels. Recall that our 95% confidence level version is P hat plus or minus 2 times the square root of P hat 1 minus P hat over n, where 2 represented 2 standard deviations in the normal distribution, which corresponds to having 95% within 2 standard deviations, and that's where we get our 95% confidence level from. But what if we want to do an 80% confidence level or a 99% confidence level? We could use a different value other than 2. We're going to call this value a critical value and denote it by Z star or Z asterisk. And that's going to be the critical value corresponding to the confidence level that you choose. So we have a table with these critical values in it. Notice that the 95% critical value is actually 1.96. It's not 2. 2 is the rounded version of 1.96. So where do these values come from? We'll draw the normal distribution to illustrate. So let's draw our normal bell-shaped curve. I'm going to leave a little bit of room below to write some numbers. And in the middle of the curve, we have 0 standard deviations away from the mean. We already know that approximately 2 standard deviations away from the mean has 95% in it. Well, that's your values 1.96 and minus 1.96. We used to call that value 2. We rounded it for you. That's where the empirical rule comes from. The actual value is 1.96. So if we think about 1.96 standard deviations above or below the mean, that's where 95% of the observations in a normal distribution lie. And 1.64 standard deviations away from the mean has 90% between it. So if we shade it in this area, that would be 90%. So these values on the table for the critical values and confidence levels are just the number of standard deviations, or the critical value in the normal distribution, that has that percent between them. You don't need to memorize this table. If you need to use it, we will always give you the values. I just wanted you to know where they came from. Now we're going to apply this table of critical values along with the results of the class poll to construct an approximate 95% confidence interval for the true proportion of college students who engaged in binge drinking in the past year. So our formula for our confidence interval now is P hat plus or minus Z star times the square root of P hat times 1 minus P hat over n. So we need several ingredients here. We need our n, so we can compute our standard error over here in the square root, and n is 120. P hat we calculated at the beginning of this lecture to be 0.58. And Z star, for 95% confidence, we just discussed, and you can read it from the table, is 1.96. We're going to put these ingredients together to calculate our confidence interval. So our formula says P hat, which is 0.58, plus or minus Z star, which is 1.96, times the square root of P hat, which is 0.58, times 1 minus P hat, which is 1 minus 0.58, divided by the sample size of 120. And copying this down to the next step, we have 0.58 plus or minus 1.96, and then we get to compute that square root. And if you punch that in your calculator, you should get 0.045. And we'll take it one step further. 0.58 plus or minus 1.96 times 0.045 is 0.088. putting this together into our confidence limits, we have 0.58 minus 0.088, which is 0.49, and our upper bound is 0.58 plus 0.088, and that's 0.67. So this is our 95% confidence interval using our more refined formula. Now we're going to practice interpreting the confidence interval. Remember, we always start out by stating the confidence level. We are 95% confident that between 49 and 67% of all college students, or whatever our population is, engaged in binge drinking in the past year. The key things to notice in this confidence interval interpretation is that we stated our confidence level. We stated our confidence limits, 49 and 67%. We put units on there because we had it in a percent form. We have our population, not our sample. So we talk about all college students, not just the ones in the sample. And the parameter, the percent who engaged in binge drinking in the past year. Now we're going to talk about understanding a little bit deeper about confidence intervals. Most confidence intervals are of the form that we've been using, your estimate plus or minus your margin of error. A 95% confidence interval is formed under the knowledge that 95% of all the possible intervals, based on every possible sample from the population, will cover the parameter and the other 5% will miss. A picture to illustrate is that you're trying to estimate the true proportion P. Some confidence intervals, when you compute their limits, are going to contain that true proportion P, that parameter. But every now and then, you're going to get some that are going to miss it completely. A confidence interval, the confidence level, says what percent of times your confidence interval will catch the true parameter if you were to repeat this procedure many, many times. Now, why do we use the word confidence instead of probability? Some of you may have been wondering that this whole time, because when we look at areas under the normal distribution, we told you they correspond to the probability of seeing a value fall within that interval. But then when we interpret a confidence interval, we call it confidence instead of with 95% probability. Well, imagine this. When you're rolling a die, before you roll it, what's the chance that you roll a 2? 1/6. But then once you roll the die, what's the chance that it's a 2? Well, it no longer has a 1/6 probability of being a 2. It either happened or it didn't. At that point, it's either 100% or 0%. Same situation with a confidence interval. Before you compute it, the way that we cooked up the method to compute it tells us that there's 95% probability or a 95% chance of that interval containing the true parameter. But once we take our sample, it's like we've already rolled the die. So once we take our sample and compute our confidence interval, it either is one of the ones that missed or it's one of the ones that hit. And we don't know which one. So the probability is either 0 or 1 at that point. It no longer has a 95% chance of containing the parameter. It either happened or it didn't. And the way we get around that issue is by calling it 95% confidence rather than 95% probability. Therefore, it is incorrect to use the term probability when you're interpreting a confidence interval. We always use the word confidence. There's no synonym that takes the place of it. It's a statistical term at this point. All right, 95% is a confidence. 95% is a popular confidence level, but we can compute other confidence intervals for any level of confidence we care about. It's just you're most of the time going to see 95% confidence. We learned to compute a 95% confidence interval for the proportion p, but we have methods to make confidence intervals for many other population parameters. We're just not going to learn those methods in this class.